Here I'm displaying an R console. You could access this in any R interface you want, including the default R GUI or R Studio or something else. And I'm going to walk through a code file that you can find on my website. This is a very simple example of some basic analysis with a within participants manipulation using linear mixed modeling. And in this actual example, it would be common and reasonable to simply use a mixed ANOVA here instead of linear mixed modeling. But today I'm going to only show the more general purpose linear mixed model approach because I'm planning to cover repeated measures and mixed ANOVA models later in the semester. The first thing that I've done is load 3 packages that I'm going to use today: NLME, LME4, and the CAR package that I often use when doing regression demonstrations. And I'm going to make some fake data to use for this example. This is included in the code file. It's a very simple fake data set. First, I'm going to create a data frame that includes 3 columns. This is from a hypothetical experiment where there are 12 participants randomly assigned to one of 2 conditions, where 0 for hiring represents a dating context, not a hiring context, and 1 represents a hiring context, where participants evaluate both a tall candidate and a short candidate. So every participant evaluates 2 candidates, but half of the participants, that is 6 of the participants, are evaluating them for a job, and the other half of the participants are evaluating them for a potential date. And then eval stands for evaluation, so eval.tall is their evaluation of the tall candidate, and eval.short is their evaluation of the short candidate. This is how the data frame might look at first when you read it in from the spreadsheet where you kept track of your experimental information. Each row currently represents 1 participant. The hiring variable indicates which condition that participant was assigned to, 0 meaning dating and 1 meaning hiring. And the eval.tall and eval.short columns represent the 2 distinct evaluations of the 2 candidates that participant evaluated. For example, participant 1 was in the dating condition, rated the tall applicant with a 5 and the short applicant with a 1. Before doing the kind of analysis I'm going to show you today, you would need to convert this kind of data set to long form. And to accomplish that here, I'm going to use the reshape function. This function can convert a wide data set to long or a long data set to wide. In this case, I'm taking a wide data set that has 2 columns representing evaluations and converting it to long form where it will have 1 column representing evaluations, but twice as many evaluations contained within that column. The first argument is the wide data set, which I've just stored as dat here. The second argument that I've provided indicates which direction I want to transform it. I'm taking it from wide to long, so the argument there is just the string long. And the next argument that I provide is information about which of the columns are varying that I want to combine into a single column, and those are eval.tall and eval.short. The result of this function call is to create the new data frame dat_long, which looks like this. And the reason I chose such a simple example with only 12 participants, only 24 total evaluation observations, is so that we would be able to look at the entire thing on the screen like this. Obviously, in a real use case, you wouldn't simply view the entire data set at the console. So here there are 24 rows. They represent 12 participants, repeated twice each, but it's the same data that was shown in wide form a moment ago. Now the eval column is like the 2 evaluation columns stacked on top of each other, and we have a new time variable indicating which condition we're talking about, an ID variable indicating which participant we're talking about. Of course, time is not a very good name for the condition that the participants were assigned to. The reshape function by default refers to the within participant variable as time, no matter what it actually represents. So here we'll change the name of that variable to height so that it's more sensible. Now I'm going to view the long form data again. It's the same data set, but now that column is referred to as height. I'm going to keep the name of the ID column because that's a perfectly reasonable thing to refer to the participant number. Here is the str structure function called on the long form data. We can see that it has some attributes added in to keep track of what was done when we transformed it from wide to long. But most importantly, in this case, we can see that height is a character vector and ID is an integer vector, and both of those should be factors. We're going to treat both of them as categorical variables in our analysis. Height is going to be one of the fixed terms in our model, and ID signifies the grouping variable for our random intercept. So I've converted both of them to factors.